The ODB project is funded by the Demo Wind programme, which is part of the European Union's Horizon 2020 funding scheme, and it is looking to develop and demonstrate 7 novel blade technologies that will be retrofitted to field turbines and demonstrated in the field. The project is made up of 10 partners from across 4 countries and has a total project spend of over €4 million, of which the Demo Wind programme is providing €2.4 million worth of funding.
We are hosting the meeting for all the partners, so they come to Valencia during this week to share the advances on the task development of the agenda of the project. And it's really good to have them all here, and for us it's a pleasure to host this event. CEU is participating in this ODB project, Offshore Demonstration Blade project, as a partner in a technological way. We support the numerical methods, technologies related to computational methods in terms of developing new materials for wind turbine blades applications. We close work with Aerox and Siemens Gamesa on these work packages.
Our contribution to Offshore Demonstration Blade is an innovative leading-edge protection solution which we've transferred from the helicopter industry using nickel plates that have been electroformed to protect the leading edge.
And in this project we are contributing with one of our 11 patented structural enhancement technologies for wind turbine blades. This one is a cross reinforcement called the X stiffener. It is to prevent shear distortion in the main box. This is to avoid peeling in your bond lines, avoid peeling stresses in the bond lines from your shear webs to the spar.
TecEner is a research organization, and within this ODB project we develop sensors. Sensors are important because if you want to know what the structure is about, you need sensor input in order for the models to quantify what is happening. Within this project we developed one sensor that's entitled cross-sectional shear distortion, and the other one is the erosion sensor. That are both two problems that can happen with the wind turbine blade, and with these developments we try to solve this problem.
As a wind turbine manufacturer, the noise is an important issue that we need to continuously improve it. The target of the project that we are developing is to develop new devices that can reduce noise, and in this way trying to, at the same time, to increase the energy production that we can later on supply to our customers. And this is an important fact because it has some important benefits in terms of energy, but also in terms of health, because we can reduce the noise impact of the wind turbines to the wall.
The EUDP Demo Wind project to support the other technologies in this project. Our main contribution is field service experience, being out in the field, knowing the technologies from the practical point of view.
TecEner in this project is going to design low drag porter generators that are some devices that are to the place of wind turbines in order to delay separation. They have the characteristic of increased also lift coefficient, but they increase drag coefficient, that is their main drawback. So TecEner's role in this project is to design low drag porter generator that has very good characteristics but decrease drag.
In Aerox, we produce coatings and adhesives for the wind industry market. In this particular project, we are developing a coating which is a leading-edge protection for the blade. This product is developed under a technology which is called AHP, Advanced Hybrid Polymer Technology. This technology allows us to modulate the properties of the polymer, which is related to the conditions where the turbine is going to work: temperature, humidity, number of droplets, or location.